This animation presents the scenario of solid waste management in India and gives a sensible solution to the problem. In the year 2009, Controller and Auditor General estimated that amount of solid waste per year was 48 million tons, but in the same year, assessment by Department of Economic Affairs reported 58 million tons. Pollution Control Board gauged 47 million tons per year in 2012. Planning Commission Committee chaired by Kasturirangan in 2014, evaluated 62 million tons per year. Recently in 2016, Central Pollution Control Board showed a figure of 52 million tons solid waste per year. According to the latest Central Pollution Control Board report, in 2016 only 23% of the total waste is processed, taken to landfills or disposed using other technologies. In 2016, Waste to Energy Research and Technology Council determined on a wet weight basis, which consists mainly of a large organic fraction, 40 to 60%, ash and fine earth, 30 to 40%, paper, 3 to 6%, and plastics, glasses, and metals, each less than 1%. Most cities have already made available all the land they could afford for landfills, and new land will be almost impossible to provide. By the late 2000s, the idea of converting waste to energy had caught the mind of policymakers. Waste could be processed to make fuel, which would be burned to power or burned directly so that electricity would be generated. The status of refuse-derived fuel plants in India is not a good sign for the future, and many plants in India have already been shut down. Among 34 RDF plants in India, only 8 plants are working and few plants are coming up. The main reason for the failure of RDF plants in India is the lesser amount of waste and the low electricity production. Lack of facility for the purification of flue gas from the RDF plants are also a primary reason for the shutdown of most of the plants. For successful waste management, vermicomposting and anaerobic digestion units, biogas plants, recycling units, and waste-to-energy power plants are a must. Purely organic waste is disposed in vermicomposting and anaerobic digestion units, or biogas plants, recycling units for source-separated marketable materials, and remaining all type of post-recycling mixed wastes are combusted with energy recovery. In this animation, we mainly focus on the final stage of waste management, the waste-to-energy power plant. In Amsterdam, AEB power plant processes 4,000 tons of domestic and commercial waste each day. It is essential for optimal combustion that the waste is of uniform quality. This is why it is mixed in the waste bunker. Large crane then transfers the waste into the focus of the furnace. This will be a continuous process of 24 hours a day and 7 days in a week. Temperature on the moving grate is maintained between 100 degrees Celsius to 1200 degrees Celsius. This heat is not wasted. It turns water in the furnace valve or boiler water in the oven to steam. This steam passes through the turbine at high pressure, and turbines drive the generator. This generates electricity. After the electricity production, the exhausted steam from turbine may also be used for industrial heating, by co-locating industry next to the waste-to-energy plant. Part of the waste is incombustible. This part which remains after combustion is called bottom ash. Technologies are there to wash and recover the metals from the bottom ash. A large amount of ferrous and non-ferrous metal like aluminium and copper will be returned for recycling. The rest is cleaned further and divided into the sand and fine powder and unburnt scraps. High-quality materials for building roads are obtained from the sand and fine powder. The unburnt waste reaches the furnace again. After the energy recovery process, the flue gas is cleaned. This is the longest part of the production process. The air pollution control system includes ammonia injection to reduce nitrogen oxides, dry or semi-dry scrubbers to remove hydrogen chloride and sulfur dioxide, and activated carbon injection to capture volatile metals and dioxins. The cooled gas passes through a fabric filter bag house, where the particulate matters are removed. The clean gas conveyed to the stack contains only nitrogen, water vapor and carbon dioxide, and must meet the stringent European and American standards. 10% carbon dioxide from the waste-to-energy power plant could be converted to produce methanol for fueling automobiles. A well-established technology from Iceland using carbon dioxide, water, and solar energy will reduce the carbon footprint of the WTE power plant. Most of the existing waste-to-energy power plants are located at a distance of less than 5 kilometers from the center of the city. They range in size from 1,000 tons to 4,500 tons per day. For example, ABR Energy at Rotterdam consumes nearly 4,500 tons of waste per day, which produce 64 megawatt electricity. To clean the southern part of India, first we have to implement at least 100 waste collection and separation centers WCSCs, few recycling units and one waste-to-energy power plant. Each district should have at least 3 WCSCs. That means one waste collection and separation center is needed for every 60 square kilometers. Purely organic waste is disposed in the local vermicomposting or biogas plant at WCSC. Waste-to-energy power plant in South India will require 4,000 tons of waste per day, similar to ABR Energy or AEB Amsterdam. So it is advisable to use Indian Railways to collect waste from WCSCs to the waste-to-energy power plant, thus it would be easy to reach the huge amount of waste from the cities even 500 kilometers away from the plant. After a successful waste management in the South India, we will make use of this experience to clean India and the entire planet.